Day 441 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 2163, minimum difference in sums after removal of elements. The difficulty level is hard, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, subscribe, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given a zero-index integer array nums consisting of 3 times n elements. You're allowed to remove any subsequence of elements of size exactly n from nums. The remaining 2 times n elements will be divided into 2 equal parts. The first n elements belonging to the first part and their sum is sum first. The next n elements belonging to the second part and their sum is sum second. The difference in sums of the 2 parts is denoted as sum first minus sum second. For example, if sum first equals 3 and sum second equals 2, their difference is 1. Similarly, if sum first equals 2 and sum second equals 3, their difference is negative 1. Return the minimum difference possible between the sums of the 2 parts after the removal of n elements. All right, y'all, so that may seem a little bit confusing at first, so let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So in example 1, we have the input nums equals an array of integers 3, 1, and 2. So that lets us know right off the top, right, it says nums consisting of 3 times n elements. So since there's 3 elements, that means n must be 1. Then it says the output is negative 1. Explanation says here nums has 3 elements, so n equals 1. N equals 1 because 1 times 3, the 3 elements, is going to give us 3, right? Boom. We have 3 elements, and n is equal to 3 times n, right? So, or excuse me, the count of the elements is equal to 3 times n. So if there are 3 elements, 3 divided by 3 is going to give us 1. So that's how we know n equals 1. Then it says, thus we have to remove 1 element. So since n equals 1, we have to remove 1 element from nums and divide the array into 2 equal parts. So if we remove nums of 0, which is equal to 3, the array will be 1 and 2. The difference in sums of the 2 parts will be 1 minus 2, which gives us negative 1. So if we remove this 3, we'll be just left with this 1 and 2, right? Because we have to remove, what does it say? It says remove any subsequence of element size exactly n. So since n equals 1, we have to move, we can remove exactly 1 element. So if we remove this first element, if we remove the 3, then we're left with this 1, 2, right? We'll be left with 1, 2, and the difference in sums of the 2 parts will be negative 1 minus 2, which gives us negative 1. So once we remove the 3, we'll be left with 1, 2. So that will mean 1 will be our sum first and 2 will be our sum second. Then we find the difference in sum by doing the sum first minus the sum second. Boom, just like that. And that's how we get negative 1, right? Because this would be sum first, this would be sum second. When we subtract them from each other, we subtract, or we do 1 minus 2, we'll get negative 1. Then, but we're not done yet because we have to try all the possible combinations, right? So if we remove, say we choose to remove the 1 instead of the 3. If we remove nums 1, which equals the 1, the array will be 3 and 2. The difference in sums of the 2 parts will be 3 minus 2, which is equal to 1. So if we remove this, we'll be left with just this 3 and the 2, and now this 3 is sum first and this 2 is num second. When we subtract those from each other, we'll get 1. Then we try our last one where we'll remove this 2 and see what happens. So if we remove nums 2, which is equal to 2, the array will be 3 and 1. The difference in sums of the 2 parts will be 3 minus 1, which equals 2. The minimum difference between sums of the 2 parts will be 1, 1, and 2, and negative 1 is the minimum difference, right? So if we do 3 minus 1, that's going to leave us with 2. That's after we remove the 2. If we remove the 1, then we'll have 3 minus 2, which is going to get us 1. But if we remove this 3, we'll have 1 minus 2, which will get us negative 1. And since these are the three differences that we will be able to create, and since negative 1 is the smallest, that's why we return negative 1, hence the name of the problem, minimum difference in sums after removal. Negative 1 is the minimum sum after removal, and that's why we return it. So I hope that made sense to y'all, but just in case it didn't, let's take a look at example 2 where we have more elements and n is a little bit bigger, right? So in example 2, we have nums equals the array of integers 7, 9, 5, 8, 1, and 3. This time the output is 1. Explanation says here n equals 2, right? So n equals 2 because we have 1, 2, 3, 4, 5, 6 elements. So, and since we know that nums is consistent of 3 times n, so we have to do 6 divided by 3, which is going to give us 2. So now we know that n is equal to 2 because, once again, 6 divided by 3 is equal to 2, which means since n equals 2, we must remove 2 elements and divide the remaining array into 2 parts containing 2 elements each. So if we remove nums 2, which is 5, and nums 3, which is 8, say we remove these 2 elements right here, we'll be left with an array of integers 7, 9, 1, and 3. And the difference between the sum will be, so we'll split it up into 2 groups again. 7 and 9 will be sum first. 1 and 3 will be sum second. So when we do 7 plus 9, which is 16, minus 1 plus 3, which is 4, we'll get 12. Boom. And that's when we remove these 2 elements. To obtain the minimum difference, we should remove nums 1, which will be 9, and nums 4, which will be 1. The resulting array will be 7, 5, 8, and 3. So we're not going to go through all the removals like we did in this problem because there's so many, but to get the minimum difference, it's letting us know that we need to remove nums 1, which is 9, so we need to remove this 9, and we need to remove nums 4, which is this 1. So we remove this 9 and we remove this 1, and that's going to leave us with the array of integers 7, 5, 8, 3. The difference of and the sums of the 2 parts will get 7 plus 5 will be sums 1, 8 plus 3 will be sums 2. When we subtract it, that will be 12 minus 11. That's going to give us 1, and it can be shown that it is not possible to obtain a difference smaller than 1. So that's why our output is 1, and that's how we got it. We removed the 9 and we removed the 1, and that got us to a difference of 1. So now that we understand the question, y'all, let's get into the fun part, the actual solution. Solution is not that difficult to understand at all, so let's get into it. Now, the first thing is we're going to do is we're going to get the total number of elements in the array, because we're going to need that when we're trying to figure out what n is. So we're going to say, for that, we're going to say, come right here, we'll say capital N, set that equal to nums dot count. Boom, just like that. Then we need each segment will be of size n divided by 3, right? So, or capital N divided by 3. Sorry, no, n, lowercase n, that's going to be capital N or nums dot count divided by 3. So to get that, we're going to say let lowercase n equal capital N divided by 3. And that's going to get us our lowercase n for us. Then we need a max heap for keeping track of the largest elements in the left part. So we'll declare a variable called max heap, set that equal to heap less than and greater than, and put the parentheses outside to initialize it. Then we need an array to store the minimal sum of the smallest elements from first and to n elements. So for that, we're going to say declare a variable, and we are going to say left sum. We're going to set that equal to an array of integers, come outside of that, open up the parentheses, and just to initialize it, for a default value, it's going to have repeating zeros, comma, count is going to be colon 2 times n plus 1. Just like that. And then we're going to need the running sum of left and smallest elements, or we need to store that somewhere. So we're going to declare a variable called sum L, and we're going to set that equal to 0. Now we need to fill the initial heap and compute the sum for the first n elements. So to do that, we're going to say for I in 0 less than n, we're going to open up the brackets just like that, and we're going to say max heap dot insert, open up the parentheses, nums square bracket I. Boom. Then we're going to come underneath that, and we're going to say sum L. That is going to, we're going to say plus equals nums square bracket I. Boom. Just like that. Then we could come here, or now we need to store initial left sum at position n. So we come underneath this, and we can say left sum square bracket n. We're going to set that equal to sum L. Just like that. Now we need to slide the window to include more elements and always keep n smallest by removing max from the heap. So to do that, we're going to come underneath this, and we're going to say for I n. Sorry, y'all. I don't know why my keyboard is lagging like that. We're going to say n less than 2 times n. Then we're going to open up the brackets. This should be 4, not 4. Sorry about that. So we're going to say 4. Then we are going to add the next element to the heap by saying max heap dot insert, open up the parentheses, nums square bracket I. Then we could come underneath that, and we could add the current sum by saying sum L plus equals nums square bracket I. Boom. Come underneath that, and we need to remove the largest element from the heap to maintain n smallest. So we're going to say sum L minus equals max heap dot pop max, and put the parentheses. Then we need to store the sum of n smallest for the current window. So to do that, we come here and we say left sums square bracket I plus 1, and we're going to set that equal to sum L, just like that. Now we need to create a min heap for keeping track of the smallest elements in the right part. So for that, come right here, we can declare a variable called min heap, and we're going to set that equal to a heap less than sign and greater than sign, put the parentheses. So then we're going to need a variable for the running sum of the right and largest element. So we could say var sum R, set that equal to 0 to start, and we need to store the sum of n smallest for the current window by, we need to store the result, or we need a place to store the result to store the minimum difference found. So we're going to say var ands, and we're going to set that equal to n dot max, just to start. Boom. So now we need to initialize the min heap with the last n elements, or the rightmost elements, for the second sum, or sum second. So we're going to say for I n, open up the parentheses, 2 times n dot less than, so up to capital N, come outside of those parentheses, dot reversed, we're going to open up the brackets, and we're going to say min heap dot insert, open up the parentheses, nums, square bracket I, and then we're going to come underneath that, and we are going to say sum R plus equals nums, square bracket I, just like that. Then we need a variable for the current sum of the right and largest elements. So we could come underneath this for loop, declare a variable, and call this right sum, and we'll set that equal to sum R. Boom. Now we need to slide the window backwards through the middle third of the array and compute the minimum difference. So to do that, we are going to say, come underneath this, we're going to say for I n, open up the parentheses, n, lowercase n, dot, 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 2 times lowercase n, come outside the parentheses, dot, reverse, put the parentheses, open up the brackets, and we need to say, we're going to say if I is less than 2 times n, then we can open up the brackets. And we're going to add the current element to the heap. So we're going to say min heap dot insert, open up the parentheses, num, square bracket I. Then we're going to come underneath that, and we are going to say we need to add the current right sum. So we're going to say right sum plus equals nums, square bracket I. Then we're going to come underneath that and remove the smallest to keep n largest elements by saying right sum minus equals min heap dot pop min, put the parentheses. Then we come underneath this this if statement, but still inside the for loop, and we say we need to update the answer with the minimal difference by saying ands equals min, open up the parentheses, ands, comma, left sum, square bracket I, minus right sum, square bracket I. Or excuse me, not square bracket I after right sum, just right sum. Then we come right here, and we could just return the minimum difference that we have found, or the i.e. the answer, by saying return ands. Just like that, y'all. That should be all she wrote. Let's go ahead and give it a run. Okay, value. What is our error? Must be unwrapped. So let's see where we went wrong here. So let me see, y'all. Give me a moment. Let me see. Oh, so we gotta put an exclamation point. We could just force unwrap it like that. Let's see. Let's give that a run. See if that works. Cannot find left sums. That should be left sum. Let's run it again. See what happens this time. Okay, must be unwrapped. We gotta unwrap this. Exclamation point. Let's run it again. Okay, cannot find let sum. That should be left. Sorry about all these errors, y'all, but we'll get there. We get in there. Let's see. And it's accepted, y'all. So let's go ahead and submit it. Make sure it's still accepted after we submit it. Let's see. Ooh, look at that, y'all. 48 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So, with that being said, make sure you get one more look at the code. This is the top part. This is the middle part. This is the bottom. And boom, y'all. Hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.